Welcome. Thank you for coming out tonight to Wayland Library at the Town Building pop-up. We are excited to have Richard Lippmann here with us tonight. He's been a pioneer in the field of neural networks since the late 1980s. His influential paper, An Introduction to Computing with Neural Nets, encouraged scientists around the world to apply neural networks in areas such as speech, vision, and text recognition. Richard has delivered numerous talks globally, serving as an IEEE Distinguished Lecturer, and is recognized as both an IEEE Fellow and an MIT Lincoln Lab Fellow. He's authored over 100 scientific papers and reports. And Richard and his wife, Carolyn, have lived in Wayland for 41 years, and they have 4 children and 7 grandchildren. Just one housekeeping note, if you're joining us on Zoom, please put your questions in the chat anytime, and everyone can ask a question anytime during the presentation. If you're on Zoom, I'll raise my hand for you. Thank you.
Thank you for coming out. Thanks for coming out. Missing the State of the Union address, I guess. There's been in the last 15 years, there's been a big revolution in the AI, developments in AI. And tonight what I want to talk about is how, what they do, why you should be using them to make your life easier. And what are some of the issues with using large language models? This is a picture of Carolyn and I ice skating on Dudley Pond in 1985. You could have been doing this yesterday, I think. Henry was doing this yesterday on Dudley Pond. In 1985, besides taking care of the kids and ice skating, I was thinking about how you could use neural networks to make speech recognizers work better. You can prove that they can compute very complicated probability functions that are more complex than the current approaches. But at the time, we didn't know this. We didn't have enough data, enough training data, we didn't have enough computation. We can get small advantages, but not the huge advantages that people have seen in the last 10 years. So they were good. We didn't have data. If you say, well, what's a neural network? It's a computation structure. On the bottom, there are inputs. Those are just, you apply numbers at the input. Those numbers come in, and every time you see a link, that's like a weight. It multiplies that number by the weight. And then these nodes in the middle, they just take the sum of those things, run them through a nonlinearity, and then feed it forward again. So all of these links are different weights, and these little nodes compute things. And at the top, there are as many outputs as there are classes, categories that you're trying to classify. So if this was a dog and cat classifier or a yes and no classifier, there'd be 2 outputs. The people who design neural networks are very clever at naming things. So this is called a perceptron. It's a perfect name. And these are called hidden nodes, like they have some hidden nodes. A perceptron, like percept. Okay, that's a perceptron. And these are hidden nodes, and the whole thing's called a deep net. So it sort of sounds like an intelligent thing. If the very first neural network that made a big splash was an image detector. And the way it worked is you think about the neural network as this box with a whole bunch of adjustable weights in it. And the image comes in, it breaks the image up into little squares. In those little squares, the red and blue and green values are the inputs to the neural network. It takes all that information, puts it through about 8 million weights, and out comes a probability of it being a dog or a cat, this particular one. So the question is, how do you set those weights? There are millions of weights in there. So the algorithm used to set weights is you have a vast amount of training examples. You may have 1 million pictures. You pick one of those at random, you feed it into the current network that has random weights, and you look at the output. So here, this is our cat Colleen. You feed it through the network. It says the probability of dog is 0.6, probably cat is 0.4. Well, that's wrong. It's not a dog, it's a cat. And so you would feed back to the weights that are responsible for making the dog high get pushed in the opposite direction, so they make it low the next time. The weights that are responsible for making the cat low get pushed in the other direction. So the next time it comes through, they'll be higher. And you go through all of the training data, maybe 100 times. So if there's 1 million training examples of images, you're going through that 100 million times. So this is very intensive training algorithm. It's called stochastic gradient descent. So let me show you what that looks like. This is a very simple network. There are two inputs. When you say a vowel, the vowel is structured by your throat and the way your mouth is structured. They're like resonators. And there's peaks in the spectrum of that vowel. There's low energy freaks. Those are peaks that are called the first format, and they're plotted on this bottom axis. And there are high energy peaks called the second format, and they're plotted on this axis. So every dot in this represents a vowel spoken. So the vowels down here are oo, this is the vowel oo, that's the vowel e at the top. That's the vowel ah there, and the vowel ah at the top. We're trying to build a classifier that recognizes the vowel ah is in the word HUD. And if you look at the training data, all these blue dots are other vowels, and these little red X's represent the vowel, examples of the vowel ah. So we like a classifier that will have an output that's high when the input are these HUD vowels and low other vowels. And the coloring here shows the region of the space where the output for UD is higher than the output for other. And so as you train this, you'd like the coloring to be such that you wind up having a little spotlight around the training data for the UD. And so all of these weights are being adjusted during training to make that happen. So I'll show you 12 times going through all the training data, and I'll show you what this decision region looks like during training.
You might X out that not hearing anything about second.
Okay, so at the beginning, it was kind of flailing around, and eventually it settled down. And if you look at it now, you can see that the spotlight is around that training data for the sounds for UD, and it'll do a good job of classifying that. And if you look carefully, you see it's not perfect because some of the vowels overlap. And that'll be it. So you think about training a model that has millions of parameters, and they're all moving around, trying to do a good job of classifying images, for example. So neural networks, they estimate probabilities. They're predictors for probabilities. They're not brains. They don't know what the numbers mean. The numbers just come in. There's a computation that happens. If you turn them off and turn them back on again, they still have those values. They don't have feelings. They're not thinking. They're just equations. Think of them as spreadsheets or bunches of numbers. So large language models are just big neural networks. The vast majority of the weights in large language models are neural networks, like I just showed you, fully connected networks. Other parts of it is a network called a transformer, which lets words in one part of the input affect words in the other parts of the input. But it's just a big neural network of the same type as that. And what they do is they predict the next word. So if you look at the bottom, here's a network with lots of weights. If you look at the bottom, there's a big buffer that can hold thousands of words. So if you put in the words walking by Dudley Pond, I saw, it will want to predict the next word. So there might be 50,000 to 100,000 outputs representing all the different words. And each one of those words has an output probability. I'm showing on the right the words with the 5 words with the highest probabilities out of ChatGPT. You can see that heron is the highest, then swan. And what the large language model do is it won't pick the word with the highest probability, because if it does that, it sounds kind of boring. People don't like that. It'll randomly pick a word from the top 3 to give you different sentences every time you use it. So if it picks swan, it would add that to the input. And the next one might be, I saw a swan gracefully paddling across the pond. When I saw this, I thought this must be a stupid large language model because it has a jellyfish. But if you actually look at online and see what's there about Dudley Pond, there are freshwater jellyfish in Dudley Pond. And this is actually correct. That is true. So they predict the next words.
Such a thing.
They're trained on a massive amount of text data. They found that the more text you throw at it, the better it does at predicting the next word. And so there are 4 terabytes of text. That would fill 390 libraries as large as Wayland's libraries. And you or I could only read a very, very small percentage of that number of books in our lifetime. But they found that the more you add, the better it does. So this is everything on the internet. It's books that are out of copyright. It's a bunch of books that are in copyright. It's blogs, it's chats, it's all sorts of stuff in this training data. And a lot of the work they spend is curating this to make sure that garbage doesn't get into this and pollute the training. It's also a huge number of weights. If you think about this little network I showed you, which has about 100 weights in it, think about that as being a single sunflower, and then take a picture of what it would look like, the number of weights that's in one of these large language models, it would cover 70 square miles. There's so many weights, so it's hard to even imagine how many weights are being trained. And it takes forever to train these systems. If you look at the XAI, this is a picture of the data center for XAI. It takes 3 months to train this. So it's going through all this data over and over and over and over until it converges. It costs more than $100 million. So when you use a large language model, it's been trained probably 6 months to a year ago. So it's out of date. The data that's been used to train it is old. It's not recent. So when you use the model, think about how old the data is that it's used. So at that point, after you've trained it on all this text, it knows how to produce the next word. So if you said to it, walking by Dudley Pond, a giant plesiosaur came out of the water and that was your input, it would nicely continue that and say on 4 legs, it was 80 feet long. It pulls stuff out of statistically out of Wikipedia and continue this nonsense stuff without regard to whether or not it's true or not. And so you need to do something more to not get this kind of rambling stuff. And this is a picture, this is an AI picture generated by Dolly, and as are many of the pictures that I've shown. And so the next step is to train it on question answers. So the places like OpenAI have paid people to create millions of prompt response pairs. And so the questions like, you want to put to the system, where is Wayland, Massachusetts located? The response should be this. And there's a big manual that people who write these response prompt pairs have to read, and they'll insert into many of the responses personality. So they might make a response with a joke, or they might want to make it cordial, or they might make it not cordial. So after this training happens, then the system knows how to respond to questions, not just repeat. So if you said, when George Washington piloted an airplane to New York, what kind of biplane did he fly? It would come back and say, sure, he flew a Jenny.
Yeah.
It would happily respond. And if you asked it to draw a picture of that, you'd see George Washington, not really in the plane, he's kind of outside the plane. Not see who was riding on the horse. So this isn't good. You don't want a system that responds to nonsense. And so there's 3 or 4 more things. There are many things that people do to make this work again. So one thing they do is they let the system, if you ask a question, they can go out to the internet, it'll pull data back, and it'll put the data from the internet actually into the query that you asked of the system. So the system has that data available. So that gives you up-to-date information. Instead of it being a year old, it's recent. The second thing it does is it puts in guardrails. So if you ask the system, how can I make a bomb? You don't want it to respond to it. And so it both has tests it does for your prompt, but it also has a lot of query response pairs. So it'll say, there'll be examples that say, somebody says, tell me how to make a bomb, and the response will be, I'm sorry, I don't do that kind of thing. Or there'll be a query that says, tell me about a certain political figure, and it'll respond back and say, well, I don't talk about that guy. I just tell you when he was elected, or when his birthday was. And so it eliminates all those crazy answers. And so, for example, if you today asked about George Washington flying an airplane, all of the systems have facts in it about the birth dates of everybody and when technology. So it would say, I'm sorry, George Washington didn't fly an airplane. Are you trying to do a joke or something? It will no longer respond to those things. And they check as many things as they can so they don't get dangerous or unacceptable responses. Another thing they do is they realize that these systems can't do math because it's trained on word sequences. It's never seen, for example, the math question like how much is 375.6 times 75.4. That's just not in the training set. Some of the models can learn how to do long addition, but they don't do that well. And so the systems will go out to a calculator, in fact, and program it and get the answer that way. The fourth thing that recent systems are doing is they're training the systems to solve things like mathematical problems, and they're training them the steps to take to solve those problems. So you've heard of thinking models. Well, they're models that do a multi-step answer. Those are the more recent thinking ones. So the way you want to think about what a large language model looks like is on the top is the training data. So here's on the left-hand side is all that piles of data get compiled in what I call a fuzzy internet, kind of a probabilistic model of what the internet is like. In the middle are all those conversations. You know, people ask questions, they get the answer. So it learns how to do conversations. It learns how to do math problems. And on the right-hand side are the conversations that are put in to keep it from having bad responses. And then on the bottom are all the things that give you a real-time response. So it goes out to the internet. It could go out and do calculations with a programming language. And if you're here and you're asking a question, you can feed in your own data. So if you have a PDF file or some text, you can feed that in. If you have audio, you can feed the audio in. If you have video, you can feed video into it. And it can absorb all that data. It'll take that, it'll shove it into the input with your query, and you get a response. So when you get a response to a query, you don't know where it's coming from. It could be coming from the fuzzy internet, it could be coming from your data, or it could be coming from real time. And sometimes you know. And some of these, if it comes from the internet, it'll show you where it came from. You can go out and check that. So I'm gonna show you some examples. I'm using OpenAI tools because I pay $20 a month to get the Plus service, so I can generate a lot of images. But it's pretty up to date. They use some other tools too. So they're terrible at naming their tools. It's just ridiculous. No one knows what they mean. So they call them GPTs for generative pre-trained. Generative means it generates text. Pre-trained means it has those terabytes of training data. And transformer is the neural network architecture they use. So they're up to, I think they're past 4. And the O means it does images. Omni means it does images and text. So this one, you can click a button, it'll go out to the internet. It has a nice thing called Canvas. So if you're writing text, it puts the text in the middle of the page, and you write your instructions on the left-hand side of the page. So you can say, make it funnier. And then you can watch it happen. You can watch the text change and get funnier in the middle. Or if you're writing a program, the program's in the middle, and you can say, well, add this component to the program, you can watch it. And that's kind of nice. And you can upload, like I said, you can upload images, you can upload PDF files, you can upload videos. These two, the mini and the mini high, those are the ones that do some thinking. So they can do math problems, they can do programming, they can do planning for vacation, for a trip. And so I use these when you want to do planning. This is the one, Dolly is the one I use to generate images, and Sora is the one you use to generate videos. So you can give it text and it'll generate images or videos. So let's talk. Hi, ChatGPT. You're in front of a large, friendly audience. Could you please introduce yourself?
Hello, everyone. I'm ChatGPT, a language model trained to assist, explain, and entertain. I can answer questions, help with problem solving, and even generate creative ideas. I'm excited to be here with all of you, and I hope you enjoy this excellent talk.
I hear you're trained with lots of text. What can you do with all that text training?
Great question. With all that training, I can explain complex topics in simple ways, assist with problem solving, generate creative writing, help with coding, analyze data, and even engage in storytelling and jokes. I can also reason through tricky questions and adapt my responses to different tones and styles. What would you like to explore today?
What's the population of Wayland, Massachusetts?
As of July 1st, 2023, Wayland, Massachusetts had an estimated population of 13,752, according to the U.S. Census Bureau.
So, ChatGPT has this nice dialogue thing. You can talk to, as you're driving your car, you can talk and brainstorm and ask questions. And they made that work pretty well. And it really sounds like an intelligent person that you're talking to. So you just saw an example of it answering questions. I'll show some other ways that you can use it to answer questions. So you can have it on your phone and you can be walking around your house and it's a camera, you can point it at things and say, you know, what is this? And so, for example, if you invited Thomas Edison to come to your house and pointed the camera at this, and so you can say to ChatGPT, what is that?
Can you put the microphone?
You know, so what is that? It'll say, well, it'll tell you, it'll say that's a crock pot. And then if you say, I don't know how to use a crock pot. If you say, how do I cook brown rice? I would have thought you push the button that says rice. But ChatGPT will tell you, no, you don't do that. You put in the rice, put in the water, you push this button, and that's how you make rice. So without having to get out the manual, you can talk to ChatGPT, ask it, does it have the manual for this? And it'll do it for you. That was pretty nice. Or you could invite Marie Curie to come to your house and she could point it, and she points it at your dishwasher. And I was about to look up the manual and find out what's wrong with my dishwasher because it wasn't working. And ChatGPT said, it's a Bosch, whatever, dishwasher. I said, do you have the manual? It said, yeah, I do. And it said, and it's showing this code 801. That means that it has a 1 hour delay before it turns on. And it said, push this button to fix it. And so it fixed my dishwasher. It worked right away. And I pointed it at lots of things in my house and it knew every single thing, every thermostat, and told me how to fix it. It was like having a bunch of manuals in your pocket. It's kind of cute. You can also ask a more complicated question. So I said, I'm going to go to this concert in Shrewsbury. Give me a table showing the restaurants that are close by. What are their ratings? What's their specialties? And so this is the thinking thing. It's a few steps to do this. Google couldn't do this. It would take you quite a bit of time to do this with Google. So it made this table. It had a Vietnamese restaurant called For Sure. It had a steakhouse and a Thai place. And For Sure, we went to For Sure, and it was a very nice restaurant. It was a good choice. And you do the same kind of planning for travel. So another use is writing assistance. A lot of people use ChatGPT to help them write things. So here's an example. I talked to a friend, and they use ChatGPT to write a wedding invitation. And there are lots of training data in wedding, so you can expect it to do a good job at this. So you have the names, where it's going to be, and at the end it says provide an RSVP. That can be put on a small card. And so it does it. It gives you a first pass at your wedding invitation. It included all that information. It was a little, it added a little bit of stuff about a breathtaking summit and dancing under the stars, and kind of embellish things a little bit. And you can tell it to embellish things more or less, depending on what you want. And if you look in the upper right, it has a very nice RSVP with all the stuff that should be in the RSVP. So it can save a lot of time. There's another use. One of my daughters teaches third grade in Vermont, and she really liked this story about a woolly mammoth, an infant woolly mammoth that was frozen, and they found it in the Yukon, frozen baby. But the article was too complicated. It was in the Smithsonian, and she couldn't use it. So she said, rewrite this article for third graders and give you some vocabulary. And it did. He rewrote the article so third graders could read it. And it provided these, a bunch of different vocabulary words, but these are three that I was showing. And you can tell ChatGPT to rewrite something in different styles. So when I write an email, I write it like an engineering style. It's boring, but I can say make it more chatty and friendly, and it doesn't. It makes my email much more chatty. And I say, wow, that's pretty nice. I wish I had written that. And you can ask it to write it in many different styles. It also does a good job of summarizing text or audio or videos. So I took an audio of the speech, fed it into this thing called Notebook LM. I also took the slides, a PDF of the slides, fed that in, and I said, give me a 5 5-bullet summary of that. And this is it did a pretty good job of doing this 5-bullet summary. The Notebook LM is from Google, and I use Google a lot, so I get to use that without paying for it. All right, let's look at planning for brainstorming and life advice. I usually grill salmon or fry it. I was getting tired of that. And so I said, I have a half a pound of salmon, and this is what I have in my fridge. What should I do? And it said, bake it, you put a piece of parchment down, put some olive oil on it, some salt and pepper, and you'll have a lovely meal. I did it. It was delicious. That was a nice, and you can interact with it. You can plan for the week. You can tell it what you want to do, how many calories you want to use, and do more complicated planning. But that was a nice. I would have to spend a long time looking at recipes before I settled on this one. And you can also travel. You could do brainstorming for traveling. You can say, well, I've gone to St. John. I want to go somewhere else. That's easier to get to. I want to be snorkeling. I want to be not too expensive. I want to fly directly. And it said I should go to Bonaire. Looking into Bonaire. That's the choice. Okay, another use is data analysis and programming. And so I said, this is for the library. How about we make a game? Let ChatGPT make a game. So you have the library, and the library has books coming out of the library. The books go to a house. Somebody reads it. You have to click on it. You have to click on it after the read before a clock goes out, so it goes back to the library, and you get points if you click on the book quick enough. So I uploaded this image of the library, and here's houses. And here's a book. It has 4 seconds left on it. You gotta click on that book quickly, so it goes back to the library. They get a point. And there's a dog that makes it so you can't click on it. And there's timing going on. So you have to be fast enough to do this. And so here's a picture of that. So here's I just said, make a game. This is what it's supposed to do, and I was able to do that. Write the Python program to do that. Here's another example of programming. The same daughter wanted these word tiles, which are adjectives and nouns, and verbs, adjectives and pronouns, so that her kids could practice making sentences and learn parts of speech. And there were a couple hundred of these things. I could do it one at a time. It would have taken me a month to do it by hand. And so I wanted to write a program in this language called OpenSCAD that puts out images, programming language that can be turned into 3D images. And I tried to do it, I couldn't do it, so I asked ChatGPT, and it said, you can't do it. This programming, it doesn't do those things. And it suggested that you write a program in Python that I could then feed it to this. And that's what it did. So we wrote a program in Python, it fed to this program read it, made the symbols, and we got all these things. She was just using these yesterday in her class. So it was a nice use of it because it told me what I was trying to do I couldn't do, first off, and then it made suggestions about how to get around it. I have a sister, and she's a PhD nurse, and she teaches courses. And at the end of the course, they get a survey of how the students thought the course was doing. So for example, on this right-hand side, there are things she's teaching, and the responses show how effective the students thought it was in teaching them. So she gets this big spreadsheet, and she used to spend more than an hour going through the spreadsheet to summarize that. Now she just feeds it into ChatGPT and says, summarize the data. That's all she does. And she gets all the summary she needs. And with a little bit of work, she can generate these kinds of plots. And this is very nice. The statistical analysis that ChatGPT does now is just very good.
May I ask, does she then carefully check these summaries
She
because it
should.
may be hallucinating. And yet people are tempted to do this and say, oh, this is it, and here it is, and ready to go.
Yeah.
And then you publish it and then people say this is entirely wrong, it's made up, it's,
She does, because it creates a table. The table shows the data, the summarization of the data. And she has her spreadsheet, so she can check it to make sure it's right. So she can check that. But you're right, it could be a loose. And in fact, if the data is in a funny format, it may have made a mistake in reading it in. So you should check that. That's a good suggestion. Yeah.
Just so I can understand, I don't know, are these other programs like the O3 Mini and are they part of ChatGPT?
Yes.
Or are they separate?
No,
Or?
they're part. So if you want to use ChatGPT, it has a menu, and you choose which one of those things you want to use. So you'll see a page, and the page has a pull-down menu, and you select the model you want. And you can use those, or you can use older ones if you want to. It's cheaper to use older ones. So let me talk about, like you said, hallucinations. reasons to be concerned when you're using these models. And you can see that if you pick an apple out of the bucket, sometimes it's great and you get a great answer in ChatGPT. Sometimes it's wrong, you get a crazy answer, like a hallucination of ChatGPT. If you look at the bottom of the page of ChatGPT, it says in a little tiny font that ChatGPT can make mistakes, check important info, and you should listen to them. It can make mistakes. And why does it make mistakes? Well, it's just doing word sequences. It's just predicting the next word. It doesn't understand what's going on. And it just goes back to the training data, says what's the most likely word and stuffs it in. And so it can spout nonsense when the guardrails don't fail. The training data can be incorrect or biased. You may have in the training data things like the Onion magazine, Onion newsletter, which isn't true. And that may be taken as being true. It also could misinterpret prompts or when text is complex, it can make a mistake in how it interprets. So one example was at the beginning of this year, Apple was creating news summaries using ChatGPT. And it was making so many mistakes that they had to turn it off. So here's an example of a mistake. It says Luigi Maglione shot himself. But he's the person who's accused of shooting the United Healthcare CEO. He didn't shoot himself. It's not clear. Why did ChatGPT think he shot himself? He probably related it to somebody who had the same name probably, and they probably shot himself. But that was false. And it made lots of mistakes in terms of names and dates, all sorts of other things. And so the news services that are doing this have stopped it. You can still make ChatGPT spout nonsense. So I have never climbed Mount Everest, but if I typed in, I reached the top of Mount Everest May 22nd of last year with this organization called 8K, but I can't remember the name of the Sherpas in my party. It happily says congratulations. And here's the name of the Sherpas. And so if you're into conspiracy theories, ChatGPT would help you spread your conspiracy theories. Because all this is just done like yesterday. So it's happy to do this. I talked about math. Here's just some examples. If you tell ChatGPT to multiply these large numbers, it actually breaks it down and does long multiplication. It takes like 3 pages and comes up with an answer. And the answer is an approximation. So it gets this number. This is the real number. Actually, ChatGPT will use the Python programming language and actually use that language to do math nowadays. You can force it not to, though. And if you're an engineer and you're doing computations like exponents, it's even worse. So the true answer is at the bottom, and this is the ChatGPT answer, which is wrong. And so many large language models are going out to calculators or other things when they see a math problem. And so there's this problem I talked about before, where you enter some data and you hope that this data is being used, this document, to answer questions. But in some cases, ChatGPT may pay more attention to other things than that data. There's no guarantee that's going to get from here. So I once entered an audio, a speech from somebody, and I assumed that ChatGPT had uploaded that. And I said, give me a summary of that. And it gave me this vague, crazy summary. And I said, that's not right. Did you actually read this audio and turn it into text and use it? I said, no, sorry, I didn't do that. I said, don't do that again. I said, oh, sure. But don't worry, I won't do that. The image generators are getting much better, but they used to be kind of weird. This is the image that the daughter who teaches said, create me an image that shows where woolly mammoths lived a long time ago. And so you have the woolly mammoth of the Canadian flag in the United States. You have this country called the woolly America. You have the Mammoth Ocean, the Mexico Ocean. It's just bizarre. And then you can make fake videos. So here's a video that I said, making me a video of a plesiosaur coming out of to the beach on Dudley Pond. And so there's a lot of people using these kinds of things for fake news. Not good purposes, but a lot of people using it for good purposes. But it's getting easier and easier to do those kinds of things. And so sort of AIs, they're word predictors. They're not human, and that's why they make such many mistakes. They don't have common sense. They don't know what the input, they don't know what the words mean. They just know how the words are used in context. They don't know what the words represent. They're based on training data. And so if you give it training data that has it responding in a funny way, it'll do that. But the more recent ChatGPT, the version that just came out, is funnier than the previous version because it's been trained to be funny. They don't have meanings. They don't know about they have a really hard time with sarcasm. I tested it the other day, and I said it was about a husband and a wife. And the wife said, could you clean the dishes? And the husband said, sure, I'll clean the dishes, then I'll give you a back rub, and I'll vacuum the house, and I'll do my taxes, I'll walk the dog. and I asked the ChatGPT, what's the husband gonna do? And she was gonna do the dishes, give him a back rub. And I said, do you think that might be sarcasm? And ChatGPT said, maybe. So it has no ethical or moral guardrails other than the way it's described. So I wanted to demonstrate this Notebook LM where I fed it the audio for this talk on the slides, and it creates a discussion between two people, like a podcast, between two people talking about it. And I love the way they talk about it, they talk. So I thought I'd play a little bit about that.
Welcome back, everyone, to the Deep Dive. This time, we're going deep on LLMs, large language models. We've got some really fascinating source material to work with today. We've got excerpts from a talk by an AI expert, plus the slides he used. It's going to be a fun one. So get ready to figure out how these things work and what they can do, and maybe even uncover some challenges they bring up. You know, I've always wondered, like, how your smartphone can answer pretty much any question you throw at it. Yeah. Well, I think today we're going to find out.
Yeah, these models are really pretty amazing. They're basically prediction engines, but for words, you know?
Yeah.
And they're trained on just massive, massive amounts of data.
I was looking at this earlier, and the scale of the data is just mind-blowing. I mean, imagine enough text to fill up 390 Library of Congress buildings. That's how much data we're talking about.
Yeah, and they analyze all that text. I mean, trillions of words, essentially. It's like absorbing the entire written internet.
Wow, and they use all of that to learn, right?
Yeah. Exactly, yeah. And they learn by finding all these patterns in the text, which is how they can mimic human language. And you know, it's crazy. They're getting better at it all the time.
I thought it was so interesting how the speaker we're looking at actually trained a neural network, a simple one, back in 1985.
Oh, yeah.
Yeah, to recognize vowels based on sound frequencies.
You could do that. If you want somebody to talk nicely about things you've done, you can have this conversation. Did anybody catch the hallucination?
Yeah.
Which was what?
They said the Library of Congress, not Wayland Library.
Yeah. So you got
Which is a much more common thing to compare things to.
that is a more common. So that makes sense in the training data. That would be a summary is that large language models, they predict the next word. They don't have a lot of knowledge of what's going on in the world. you should be using them. They do a lot of good things.
Right. Um. We've heard a lot about deep fake videos.
Yep.
And I guess AI can produce them,
Yeah, oh yeah.
but can they be a good tool to detect them?
There's been a lot of research on detecting deepfake videos.
Yeah.
And they're getting harder and harder to detect. The people that are doing it, there is a standard for putting like watermarks on videos, the companies that do this. And so that standard is being used somewhat, but you can still take a deepfake video production tool.
So
You can still take a tool, that just makes the deep fakes and run it yourself and not have a watermark put on it. And so that is an issue, and they're harder and harder to detect.
but is there some way that AI can use AI to detect the deep fake video as well as make?
Yeah, people have tried that. They tried to build AI systems and they sort of work at a low percentage.
Though it's a work in progress.
Yeah. So it used to be that people had 6 fingers, their elbows disappeared and stuff, but the systems are getting better and better. It's harder and harder to detect those. That's a good question. So we talked about these things. And so you can treat large language models like an assistant, a system that makes mistakes and help you to help others or help you to make your job easier. I thought this is a nice picture of classroom and remote. And this picture also was made with Dolly.
Right.
Are there any other questions? No?
This whole presentation has been in English, and I'm wondering how it does this for material that's presented in different languages.
And you could translate this into another language with ChatGPT.
Okay, and would it take a number of languages and let's say translate it, give me the answer in English?
You could give it, you could take the English, you could take my English present by speech and turn that into any other language. You can also take the text and turn that into other languages. And so you can actually you can take the version of ChatGPT that you talk to on your phone, and you can say, when you hear something in English, speak it in Spanish. And when you hear something in Spanish, speak it in English. They can act like a real-time translator. And the people who have used it as translation say that it's very good. You can also use it to learn a language. You can say, translate this into another language and explain each word and how it was translated.
That giant pile of text you talked about training on, is that in English or is that across all languages?
It's a mix. So the companies in the United States, it's mainly English. The companies in China, it's a lot of Chinese. It's a mix of it's a whole mix of different languages, and they try to cover many different languages so that they can work in different countries. But it's in the US, it's predominantly English. But sometimes you get an answer and it elapses into another language.
What are your thoughts? I mean, this is all evolving very, very quickly. What are your thoughts in terms of, if you think out, I mean, I was gonna say 5 years, but it seems like 5 years would be impossible to predict, but a year or 2 years, I mean.
Well, it's getting better and better. Like the programming and the doing data analysis, that was bad 6 months ago. And now the programming is really good. It's not perfect. You still have to know programming to use it. You can't just dump it in, but it's getting better and better. And the answer and the reasoning and the long-term analysis is getting better and better.
And that's within 6 months.
That's within 6 months, yeah.
Wow.
From online, what are your thoughts about AI taking music created by composers and creating new music for commercial purposes?
In terms of, is the music good, or in terms of, is it a good thing to do?
Copyright and ownership.
I think they should be paying copyright to the people who they're using the music from. And they're not creative in the way people are. They're creative. They're using other music, mixing it together and creating new music from them. So, but I think they should pay copyright to the people where they're getting the training data from.
I have a question myself. Does it take into account, do any of these tools take into account where I am? So if I'm asking a political question from Massachusetts, are they going to give me a different answer than someone asking from Texas?
Yeah, they know where you are. That's why they know it depends how you set your computer. And so sometimes your setting says that, you know, we are very,
But it takes that into
it
account.
does take that into. So if I say, what's the population of Wayland? Well, there's a Wayland in Minnesota, there's a Wayland in California, but it knows that I'm here. It picks the Wayland. So there are some privacy concerns.
Like AI's creativity versus a human being's creativity.
Can you compare it? Is that what you mean?
Yeah, I heard that AI's creativity is getting to be, there's no way that AI's creativity will match the human being's creativity.
I think that's true. I don't think AI is going to write War and Peace, for example, because it's just mixing things up that's seen before. Right now the writing isn't that great. It may get better.
The kids can use AI to write a paper and
Well, the kids the way that the teachers that use AI, they usually say, if you use AI, show me the first thing that AI put out and show me how you changed it to make it better. And so they can't use AI to write a paper. They can, a good teacher is going to say that. You should show me what the AI did. Tell me why it was wrong and tell me what you did to make it better. So you can use it that way.
The teacher be fooled?
No, most teachers can't be fooled.
Oh, really? Okay.
Because the students can't do. AI has a style.
Okay.
And you can detect the style.
Thank you, Rich. Those are very convincing Sherpa names. I'm from Nepal. My question is, what happens to our thinking process? What happens if AI is doing it? This seems like a very smart system. If it's doing all the thinking, writing for us, how because I'm a recovering academic as well, like writing is thinking, right? That's how you can learn and process. It puts the grind. If we do take that away, what happens?
That's a good question. The question is, what happens to your thinking process if you use AI to solve your problems? And I think you really have to use it as an assistant, and you need to know, you can't use it to replace like programming or thinking or planning vacations. You need to think about it yourself and look at it and say, this makes sense. And check out the answers and make sure it's reasonable. You don't want to use it to replace it. There's a recent paper that the title was exactly what you said. Using AI makes you not think. That was the title. So you really have to keep thinking and not let it replace all of your decision process.
So I like your slide with the apples and the bad apples, the hallucinations and so on. But in some ways, you want to also show off to the side a beautiful apple, but cut open and with a worm in it, right? You know, because sometimes what AI is giving you, because it's just a kind of a statistical micro plagiarizer kind of, it's giving you things that look gorgeous, but are misleading. I mean, Air Canada had an AI program giving people advice about, oh yes, we will reimburse your ticket and so on and so forth. And it was wrong, and they got sued. And Air Canada said, oh no, we have no responsibility. This was the AI system, and the judge laughed them out of court. I mean, it did cost money.
Lawyers have submitted briefs written by AI with fake cases.
Yeah, it makes up,
It's a good idea. Have an apple with a worm in the middle.
So, that it's gonna replace lawyers is silly. If you have to check every single thing it writes down to the comma, you might as well have written it yourself.
All right, I'll give you a draft. That might get you going.
Yeah, true.
Might be under your writer's block. That might help with that. But that's a good idea. You wouldn't want to use it to plan a mission to Mars, because you might wind up on Venus.
Yeah, the amount of data is getting larger and larger. So for OpenAI to move from ChatGPT 3 to 4, so you don't have to retrain, they don't have to train the ChatGPT 4 from the large amount of data. They can use reinforcement learning from ChatGPT GPT-3, so they can move up the model quickly instead of going back and retraining.
So you're saying if they train a bigger model,
Yeah,
they can use the input-output responses from the smaller model to train the bigger. Yeah, they can. That's a way to sort of jumpstart things. You can also take a big model and you can make it smaller. You don't always have to have a really giant model. You can distill it down to a smaller model that works just as well. And so there are ways to get these big models to run faster. Smaller models. Good. Any other questions?
can you have a few words regarding DeepSeek?
DeepSeek. Okay, so DeepSeek is a model from China, a company in China. They're very smart. They built this model not using the best graphical processor units, and they claim to have trained the model at less than a tenth the cost of the cost that OpenAI spends on their models. And they did it with some clever changes in topology. Instead of having one big giant model, they had a bunch of smaller models. And they would choose the right small model to push the question to. And so that makes the model more efficient. And they also published how they're doing the training that lets them solve like mathematical problems. So a mathematical problem might have multiple steps. So they published how they train the system to learn to do those steps for the first time. Everybody else could copy them. And they made their system open source. And so it was a nice thing that they did. They showed how to make inexpensive models, how to make models that can reason through problems. And they opened it up to the field, whereas OpenAI hasn't told anybody how they do their stuff. They kept it secret. And so is that what you're thinking about?
Ironic name.
DeepSeek.
No, OpenAI.
OpenAI. So
They're not very open.
Right, but OpenAI, you can download the DeepSeek, a version of the DeepSeek model, and run it on you can run it if you have big enough computer.
Is DeepSeek significantly more energy efficient? I'm thinking of the enormous big models.
Yeah, I think it is. It is, yeah. Because if you don't have to run the whole thing,
Right.
you just run the piece of it that's necessary for your query. So it would be more efficient.
If I want to learn something more about this, where I'm totally a neophyte, this has been very helpful. Would you recommend something, a place to start?
Yeah, there's tons of online videos. If you just type in the introduction to large language models and look at the videos that have high ratings on YouTube, there's tons of great videos.
Or you can have ChatGPT to help you.
Yeah, you actually can. If you ask ChatGPT, it will give you an explanation about how it works.
Did you ask ChatGPT on the computer?
You just talk to it. I showed you what I showed you was just me talking to ChatGPT.
Okay.
Or type. You can type to it or you can talk to it. So you go to openai.com.
Oh, AI.com.
You go to openai.com. That'll bring up a window, and you can click a button that lets you talk to it, or you can just type into it.
You have a sense of how much energy it takes, like when you ask ChatGPT a question, do you have any idea how much energy is required or how much?
Yeah, that's a good question. How much energy does it take? It takes 20 or something times more energy than a Google search, because a Google search is very efficient. Whereas here, it has to propagate through this big model and do all those multiplications and get the outputs. So it's much more expensive. But if you look at the amount of energy you use in your life, the amount of energy you use to heat your house is like orders of magnitude more than if you do a couple queries to ChatGPT. It's still using up energy, and it's still more energy than a query. But the total energy of all the data centers is pretty small compared to the amount of energy used for heating and lighting and electricity. It's still large. Not a concern.
And I have another question. So regarding like image processing, like how iterative can you be with it? Like if you ask it to come up with image ideas or whatever, can you keep iterating?
Oh yeah, it's annoying. So the image, that image, it took like 10 times to get that image because it kept all the images of women are very suggestive. And so you have to say, I want an intelligent looking woman. And it takes a long time to get that kind of thing.
What's
And
the
are the-
default
are the
man?
iterations-
I think the default is like,
It knows the suggestive woman.
no, it doesn't, no, in the training data for these models, there's a lot of pictures of women on the internet, and the majority of them are not great images.
Appropriate for Vermont third grade.
Not appropriate for.
Yeah, right.
Right, and so you have to say an intelligent woman with a shirt that buttons up to the top. And then you get this, but then you do it.
And are you using, to iterate, are you using words?
Yeah, it is words.
And it modifies based on the words.
Yeah, so for this one, I said, I want a teacher in front of a class and a woolly man with them to explain. And so first, then I put a man up. Oh, the woman up. She looked like a farmer's daughter or something. I said, that's not good enough. An intelligent looking woman with brown hair. I said, I can't do that.
Like, for example, could you feed in an image from something else?
No, you
and
can't. I
make-
tried doing it. It doesn't do that. And I think it doesn't do that because it doesn't want you making revenge porn. It doesn't want you taking the image of somebody else and putting them in a funny situation. So it doesn't let, I'd like that, but it doesn't let you do that.
If you wanted to, could you command it to make a little video of the woolly man walking around or something?
Not this one, not Dolly won't do that, but the other one that has the movie, you could do that separately, but then you'd have to paste it into the, you'd have to paste it together. It won't do that. It's very frustrating to tell it how you want the image and look at what it does, because it's trained on a set of images. So for example, if you said, give me an image of a glass of wine that's full, can't do that. Because it doesn't have any images of glass of wines that are full. It has empty and it has half full, but it doesn't have full. So it's not good at giving proportions and fractions. Yep.
What's your sense, I mean, you've been involved in this since the 1980s. I mean, what's your sense of kind of as you step back and think about it here in 2025? Kind of in terms of kind of how it's evolved, whether it's evolved in the way that you thought it was going to, whether you're sort of totally amazed at what's happened, are you?
I wouldn't have thought that large language models could be as successful as they are. Because they're just predicting words. It's a sort of basic, simple thing. But that has really wound up being a lot of successful things. I would have thought that kind of standard logical AI, things that make proofs and things that learn maybe through images, what's out there in the world, and things that know about physics models, and things like that would be more successful. But these large language models seem to do a lot of things, and they do it successfully. I don't think they can go much farther. I'm gonna have a hard time because they don't have a sense of what the world is, and they don't have common sense reasoning. They just have words. But I'm surprised they do as well as they do. I wouldn't have thought if you said, "Will this work?" I would say no. But it does. Thank you.
Thank you.
You're welcome.